Hey guys, so we're thinking here about this idea, building on what we know about rates and about ratios. If we use rates and ratios, we can kind of determine the type of relationship that's happening between those two quantities and determining if it sort of grows equally or predictably or not. So there's these phrases, proportional and non-proportional. So if you have a rate or you have a ratio and the two quantities that you are comparing are equivalent to each other. They're equal, right? So if you had a 3-to-1 ratio and you had another 3-to-1 ratio, well, those are equal, right? The quantities are proportional. Whereas if you proportional. If you are comparing rates or you're comparing ratios of two quantities and they are not equal, well, then by Jove, guess what? They are what we call non-proportional. So let's dig into this a little bit, kind of through this example and see if we can make some sense of this. So we have this pal, Jasmine. She's entered a baking competition and she's baking some cookies and she's baking these mini cupcakes. And these tables here below show the number of cups of sugar that she's used for each dessert after 3 dozen made. Okay. So we're going to complete each table, and then we're going to determine if the relationship of the amount of sugar she uses is either proportional or non-proportional. Okay. So if Jasmine uses 12 cups of sugar for 3 dozen cookies, then essentially what we are doing is we're taking our amount of sugar, right? We're taking our S and we're dividing it by how many dozen cookies there are. Okay, so in this case, we can say, well, in the first example here, we know that there's 12 cups of sugar in 3 dozen. And when we divide that out, because all that really is a division problem, 12 divided by 3 gets us 4. So the rate is 4. You could say, all right, well, let's do another one. Sugar divided by the dozen. So let's say 22 divided by 6. So when you do 22 divided by 6, you end up getting 3.666666666, repeating. So we can put that little hat on it. Okay, let's do another one. 36 divided by 9 gets us 4. And 45 divided by 12 gets us 3 and 75 hundredths, or 3.75. Okay, so if we look at that data, it can give us a little bit of information perhaps, but let's keep going over here with our mini cupcakes. So we're going to kind of set it up the same way. We've got our cups of sugar to our dozen. We can say, all right, in the first example, we know we have a 9-to-3 ratio or rate. So we want to divide. 9 divided by 3 is 3. 18 divided by 6 is 3. 27 divided by 9 is 3. 36 divided by 12 is 3. Okay, so as we look at this data, we could say that the sugar used in the cookies is not, or non-proportional. I'm just going to write non-proportional to the number of dozen baked because, well, we can say the rate of the sugar that she uses sort of per dozen isn't always the same. It's not equal, right? Sometimes she was using 4 cups, sometimes she was using a little bit less, sometimes she was using 4, sometimes she was using a little bit less, right? So the sugar used in the cookies is non-proportional because we could say the rate of the sugar per dozen is not equal. Okay, so if we then look at the mini cupcakes, we can say the sugar used in the mini cupcakes, well, that is proportional. And take a second and see if you can figure out why. If we know that the cookies were not proportional, and we know that the mini cupcakes are proportional, okay, you can write the real word. How do you know? Go ahead and pause the video, see if you can sort of come up with a hypothesis. Okay, maybe you had a chance to kind of come up with some language. Here's my shorthand. Boop, if you follow this crazy line, I ran out of space down here. We could say because the rate of the sugar used per dozen is equal. So whether she's making, 9 dozen or 12 dozen or however many dozen, the rate of the amount of sugar she uses is always